what we are solving for is the velocity of the plane relative to the ground. So we can write it as v plane to the ground, VPG. So mathematically, VPG is a addition of two vectors. So VPG is a vector. It's the addition of two vectors, the air velocity, VPA, plus the wind velocity, VAG. You might be wondering, how can you be sure this is the right way to set it up? A simple way is to look at the subscripts. See, the A for air is a common subscript. When you line up the vectors like this, the common A essentially cancels out, leaving this P and G for plane relative to the ground. As you can see, this equation is addition of two vectors. We can't simply add the numbers together. So let's draw this out to see what it looks like, and then we turn this into something that we can solve algebraically. Now, we know that the air velocity, VPA, is a vector pointing east with a length representing 220 meters per second. To add the wind velocity, we'll draw a new arrow starting from the very tip of our first vector and has a length representing 50 meters per second. So this is VAG. Now, VPG is the result of adding these two vectors together. We find it by drawing this vector from the very start of the first arrow to the very tip of the second arrow. So this is VPG, representing the velocity of the plane relative to the ground. As you can see from our drawing, these vectors form a right-angled triangle. This is perfect because it allows us to use the Pythagorean theorem to find the magnitude of this final vector, VPG.